let's talk about the third law of thermodynamics. It's used in every industry. Anytime you talk about cars or efficiencies, you're talking about the third law. Now, this is a typical steam engine where you take pulverized coal and put it into a boiler and it heats the water becomes steam, the steam turns the turbine, the turbine activates the generator creates electricity. So we use this all the time. And of course you see the gases escaping out. What does this actually mean? You see you have intake, you have work being done, and then you have waste. Now, in physics, this diagram is far too much to look at, okay? So let's look at this one right here. Suppose we have a hot source, okay? This is our fire, okay? This is your engine usually. So when I talk about cars and I talk about the hot source or T-hot, I'm talking about the engine. Then there's the exhaust, okay? This is the cold temperature. So this is your exhaust, okay, or your tailpipe. And then the work output is just the difference in the heat that you put in and the heat that you discharge. And the work that you're able to get out, or, this is the work that enables you to run your car. This is a very simple model, but it's one that's very useful in analyzing the efficiency of engines. Now, the formula for efficiency is very straightforward. The efficiency is the temperature at the hot minus the temperature of the cold divided by the temperature of the hot. Now, it can also be the hot heat that you put in minus the discharge heat divided by QH. And you see everything is the same except here, instead of temperatures, you have heat. In this class, we're going to primarily deal with temperatures. So the efficiency E is the hot temperature minus cold temperature divided by the hot temperature. Now, here's a trick, folks. This is the number one trick on these problems. All of your temperatures must be in Kelvin. I'm going to give you a bunch of them in Celsius. So you're going to need to remember that Kelvin is 273 plus your Celsius temperature. I'll show you in class why you can't use Celsius temperature. You get a different efficiency. Now remember, your efficiency is always going to be less than 1 and greater than 0. Your hot temperature is always greater than your cold, so this is positive, this is positive. The Kelvin scale is between 0 and, well, really, really, really big, infinity, basically. Now, the third law of thermodynamics says that absolute zero is the minimum temperature, or the point where you have minimum kinetic energy. All right? So basically it says nothing can actually reach absolute zero. Let's do a couple of efficiencies to show you what I mean. What is the ideal efficiency of a machine having a hot reservoir at 400, okay, hot reservoir, T hot, and a cold reservoir at absolute zero, TC. So E is T hot minus T cold divided by T hot. Let's see, so this is 400 minus 0 divided by 400, or 1, or 100% efficient. There is no such thing as a 100% efficient engine. So the only way to have 100% efficiency is if your cold temperature is 0. And it turns out you can't have a discharge heat at 0K, because then you would be adding heat. And by definition, 0K is minimum kinetic energy. So kind of interesting. What's the ideal efficiency of a machine having a hot reservoir of 400K, so this is T hot, and a cold reservoir of 400. So the efficiency is T hot minus T cold divided by T hot. So this is 400 minus 400 divided by 400, or 0 divided by 400, or 0. So if you're discharging at the same temperature as your engine, you have 0% efficiency. There's no energy to go into work. So this is not a very efficient engine at all. So we're going to review the three laws. The first law is conservation of energy, and that is the change in internal energy is heat added plus work done on minus work done by. The second law is the entropy law, where all things go to disorder. And the third law is our objects approach absolute zero, they hit minimum entropy. This is also where we get our efficiencies.